Chapter 14 is regarding carboxylic acids, esters, amines, and amides. Carboxylic acid is kind of like a combination of an alcohol and an aldehyde. We've talked about this carbon-oxygen double bond in the past. It was in two different things. It's in the ketone, which has carbons on either side of it. It's also in an aldehyde, which has a carbon in one side and then a hydrogen on the other. Now, if you'll notice here, this is an example of a carboxylic acid. There's an alcohol involved. So if you think of an aldehyde, but then we're inserting an oxygen in front of that H, that's what you kind of think of. Instead of referring to this as an alcohol, they're referring to it as an hydroxyl, which is essentially the same thing. It's a hydrogen and an oxygen bonded together. When you're naming carboxylic acids, there is the IUPAC way, which remember, IUPAC means systematic, and there's a handful of common names that are just memorization. So when we look at the IUPAC, or the systematic way of naming them, think of it as if we were doing alkanes. Notice here, there's a single carbon. One carbon is meth. So it's methane if it's single bonds. We remove that E, OIC acid. So, for instance, ethane, 2 carbons, it's eth. Take away the E, OIC, an acid. So OIC acid. So because methanoic acid or ethanoic acid. With this one on the bottom, we have 1, 2, 3, 4. That's where they got butane from. And then take away the E and put in OIC instead, and it becomes butanoic acid. Notice that they started counting next to the oxygen. So we counted from the right on this one, which gives us the methyl group on carbon 3. So here's an IUPAC name. That's the systematic. And here's the common name, which is the more of the memorization. It would probably be in your best interest to know both forms, because what you'll notice is that questions or when people talk, they'll use them interchangeably. For instance, they could say ethanoic, which means that you know eth is 2, so you can expect the compound to have 2 carbons. And then oic means that you have this oxygen double bond with and OH too. However, most often you'll hear it called acetic acid, which is the exact same thing. So you want to be able to memorize both sides. So some examples of when these acids are used. Formic acid or methanoic acid is used as a venom of some kind in insects. Ethanoic acid or acetic acid is actually vinegar. So when you're cooking, or when we did an experiment where we determine how much vinegar is in a product, we're actually looking at how much ethanoic acid is in there. So let's practice some namings. First thing you want to notice is that there is O double bonded OH. That means right there we have a carboxylic acid. We have actually started naming several different types of compounds now. Because of that, you want to make sure that you don't confuse them. You want to be able to point one out as being a carboxylic acid versus a ketone versus an aldehyde, and so on and so forth. Otherwise, you're not going to be able to, you're going to make them all confused. As always, you're going to find the longest chain. carbon, 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 carbon. We haven't seen this form of drawing it for a while. So remember, every time it bends and every time it ends and there's no letter. This one is not a carbon, it's an oxygen because there's a letter out here. But if there's not a letter, like here, there's nothing written, it's a carbon. So our longest chain is 5. That's pentane. Because of it being a carboxylic acid, we changed that E to pentanoic, and we add the word acid. We have one substituent that has not been named yet, and that's a methyl. You start counting from the oxygens. So 1, 2, it's on the second carbon. So it's 2-methyl pentanoic acid, and that would be our final answer. So first of all, we counted the longest chain, took that E away, and added oic instead in the word acid, so pentanoic. Then we determined our substituent is methyl, and we start counting from the oxygens, and that's where we get the 2-methyl from. Benzene, this is benzene here, or it could also be written like this. We've seen this several times before. If there's a carboxylic acid on it, it's called benzoic acid. And once again, you're always going to count from the oxygen. So in the benzene ring, we start counting with 1 next to the carboxylic acid. 2, 3, 4. So the chlorines, we have 2 of them, so it's dichloro. It's on atoms 3 and 4, carbons 3 and 4. Benzoic acid. Alpha hydroxy acids are actually extremely common, and they've also started being in products more and more and more because they've realized that it for cleansing products and for lotions and so on and so forth, because they realize it's good for the skin as well. But notice that AHAs, alpha hydroxy acid, is referring to this double bonded oxygen OH. That's your carboxylic acid. When it says alpha hydroxy, here is the carboxylic acid. Alpha is the carbon right next to the carbon that has that acid. So on the alpha carbon, there's an OH group. That's what alpha hydroxy means. So here's your carboxylic acid. Here's the alpha carbon because it's right next to the carbon in the acid. And here's your OH group. This is the carboxylic acid. This would be your alpha because it's right next to it. And here's the OH group. And that's what alpha hydroxy means. So it's been shown to remove acne scars or age spots. So it's been put in a lot of lotions lately. And it's actually been very highly advertised. There's a couple different ways to abbreviate it. And I'm going to point that out because of this right here. It could be written out like this, where you actually see all the bonds, which is the same thing as this here. Or you could see it COOH. That means it's a carboxylic acid because this O is referring to the double bond, and this OH is referring to this OH group here. You could also see it CO2H as a shortened version. So let's try naming these. So we know we have a carboxylic acid here because it says COOH. We have 1, 2, 3 carbons. Ordinarily that would be propane. Because it's a carboxylic acid, we lose the E and we change it to pro-anoic acid. Now we go back and we look for substituents. We do not have any additional carbons outside of those mentioned, so we're good. Once again, this means it's the carboxylic acid. Find the longest chain. 1, 2, 3, 4. So that's butane. Change the E to OIC, so butanoic acid, and add the word acid. Now we go back and look for substituents. We have this right here that is not accounted for, and this is your methyl. Count from the oxygen, so 1, 2, 3. On the third carbon, there's a methyl group. So 3-methyl butanoic acid. Then finally, we have C. Here's the carboxylic acid, but it's on benzene. So it becomes benzoic acid. We have this substituent, which is bromo. 1, 2, 3. 3-bromo benzoic acid. One thing I want to point out before we go on. Notice that the carboxylic acid is always at the end. It'll either be at the beginning or the end. It's going to be it's called a terminal functional group, meaning it'll be the last thing written in the chain. The reason for that is because once they reach the OH, there's no other bonds that can be formed, kind of like the aldehyde. Once you reach the hydrogen, the bonding is done. It can't go any further. Hydrogen can only have one bond. So once you reach the hydrogen here, it can't go any further. So carboxylic acids will always be at the beginning or at the end of the chain. It will never be in the middle. So propionic, 1, 2, 3 carbons. This is actually the common way of writing it. This also would have been correct. So this is the IUPAC, the systematic way, while this is the common, which is why you need to memorize both. Butanoic, because there's 4 carbons. On the third carbon from the oxygen, there's a methyl group. Benzoic acid, that's where we get this from. 3-bromo, so on the third carbon away from the carboxylic acid group is the bromine. And that is the end of how to name carboxylic acids.